Hello, 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 Kevin here, and welcome back to some Kerbal Space Programming. When we last left off, we had taken a probe on a suborbital flight entirely automated, which is fantastic. But one of the things that we discovered is that the computer system, does require a fair bit of electricity. So what we really want to do, having unlocked our automated scriptable control system, is to be able to power it for extended periods of time so we can go to the moon and to planets and other cool stuff like that. And what we really need is to unlock electrics here, because this is going to give us photovoltaic panels which allow us to recharge our batteries and that sort of thing. But we are quite a bit shy of that. Now what we could do is do a whole bunch of boring missions, try and land some contracts and pick up small bits of science. This shouldn't be here. Why is that showing up? Anyway, but instead I propose something cooler. So today what we are going to do is actually launch a Kerbal into space. And I've got a ship that is already kind of designed and built up here. It has just enough fuel to do it. We've got another scriptable control system on here. And then we've got a heat shield. So this is a 3-stage ship, and the design is that we're going to go up into a polar orbit so we can actually get the Kerbal out there and do a bunch of EVAs and get a whole bunch of science so that we can unlock a bunch of stuff and move on. So really quickly, we've got kind of 3 stages here. We have the return vehicle, which has a heat shield and the command pod and the parachute. Of course, the passenger's not going to really be doing any flying. Then we've got this main stage here in the middle that's going to worry about circularizing stuff. And let me undo. And then we've got these boosters here. And that's a little bug with Kerbal, that it doesn't undo entirely correctly. So we've got this, and it should be enough fuel. So we've got 3 stages. The scriptable control system is going to go ahead and handle the first 2, and then it will detach, and we're just going to let this thing kind of fall back to the planet when we are ready. So we're going to go ahead and write a script to do this. Alrighty, so before we dive into the scripts for this mission, we need to talk about 3 programming concepts: conditionals, functions, and loops. And these are things that you're going to find in just about any programming language that you will encounter in the wild. Let's start with the first one. A conditional is when you want the computer to do something only if a certain condition is true. So as an example, I'm going to type if altitude is greater than 500. And then I'll open a curly brace and a closed curly brace there, and I'll say print, we're over 500, right? So now, and let's say I'll, print some more stuff here, blah. So now when the computer is evaluating this code, it'll look at this condition and check if we're over 500, and if it's true, then it will execute the code that's between these curly braces. So if we're at over 500, it'll go, we're over 500, and then it'll print blah. If we're less than 500, it'll go ahead and skip over this entire block and just jump right down to output blah. Now we can also say else. Else. And I'll say we're not. And now what the computer's going to do is it'll go through, it'll see this if, and it'll evaluate it. And then it'll say, okay, if that's true, we'll jump into this block. If it's not, we'll jump into that block. And then as soon as we're done, we'll go ahead and type blah. So that's kind of a basic conditional, and you'll use this in, we'll be using this certainly in our scripts. This is something that you'll find you use a lot in programming, because there are things that you only want to run if a certain condition is true. Now, the next thing we're going to talk about is functions. Let's imagine that we had a very, very simple rocket, and we were going to say wait until stage liquid fuel is less than 0.1. So we're going to wait until we're almost out of fuel. Then we'll go ahead and lock the throttle to 0, and we'll wait 1 second, and then we'll stage, and then we'll lock the throttle up to 100% again. Right? So all this is going to do is it's going to wait until our current stage is burned out. It's going to slow us down, wait a second, remove that stage, and then speed us up again. Let's imagine, though, that we've got a bunch of stages that all have kind of the same logic. Now this gets kind of unwieldy to have to copy and paste. And let's imagine that for whatever reason, we decided that we wanted to not throttle down entirely. Well, then we've got to go ahead and change this in a bunch of different locations, and this can be kind of frustrating. Now in programming, we have this concept of functions. So what I'm going to do is I'm actually going to write a function here. I'm going to say function stage cleanly. And I'll use the same curly braces, right, to encapsulate those lines. And I'll go ahead and just copy and paste these into here, and I'll indent them so we can easily see what's inside there. Now I've declared a function, and I can actually call this by just saying stage cleanly. And I'll use these parentheses to show that it's a function. Now I can call this 3 times without having to copy and paste this stuff inside. And it means that basically whenever the computer encounters this line of code, it's going to go ahead and look up the function and run the code inside of it. But let's imagine that we do want to change that low thrust value, right? So instead of changing this to 0 up here in our function, we'd want to set it to, low thrust, or which is some sort of value. And perhaps for stage 1, we actually do want that to be 0, and we want it to be 0.3 for another, and 0.7. And we can actually pass this in as an argument to the function. And in Kerbal script, you would say parameter low thrust. We simply declare that this function expects you to pass in an argument, and then we can go ahead and use that in our code. So now we can actually stage cleanly, and this will behave differently. So we still get the ability to behave differently each time we call it, but we don't have to worry about copy and pasting all of this code. So these are called functions, and they're used in a variety of programming languages, and they're a big deal. So we're definitely going to be using these a lot. Now, the last thing I want to talk about is loops, because we're going to be using one of these in one of our scripts. And we've seen before we had, wait until altitude is greater than something. In the previous video, we had some lines like this. What we can actually do instead is say until, and then just like with those if and else statements that we had up top, we can say until altitude is greater than 20,000. And we'll use the same curly brace syntax. I can say print still waiting. And then what this will end up doing is executing this line over and over and over and over, so long as altitude is not greater than 20,000. So in practice, what you want to end up doing is, saying like, well, let's go ahead and wait a second so that we're not, constantly spamming this output. There's another form of loop which we're not going to be using today called a for loop. I'm going to go ahead and just say set my list to list A, B, C. And this is what's called an iterator. So what I can do is say for item in my list, and I'll do that same curly brace stuff. I'll go ahead and say print item. And what this will do is it will go ahead and say, okay, for everything that we have in our list, I'll go ahead and execute this block using item as the pointer for that list item. So it would say it would print A and B and then C. So these are a couple of just kind of high level, really quickly trying to explain so that we're not too lost when we're diving into our actual mission scripts. But they're general programming concepts that are kind of good to know. Alright, so having gone through that, we've actually got 3 scripts that we're going to be using for this mission, and this first one is called Vostok Boot. I've named this mission off of Vostok, which was the first manned orbital space flight, Yuri Gagarin, back when we were in the space race. And since we're sending our first Kerbal into orbit, it seems somewhat fitting, right? So, what this boot script does, and this is a cool thing about Kerbal operating systems, we can actually set a script as long as we name it something boot.ks. We can actually set this up to be the script that is automatically on the rocket when it gets on the launch pad, and it will go ahead and run. In the same way that when you boot your computer, it has some scripts that it's already going to go ahead and do, so it knows how to start up your operating system. So what we're going to do is we're going to define a function called notify. And this is just so that we can print out some messages without using print. Because before we were using, print message, something, which was great, but it did mean that we had to have that terminal open. And instead, we want to use something called the HUD text function. And this is something that's built into KOS. And this will actually display the text on the screen without us having to have the terminal open. So rather than have to type this whole bit out every time, decided we'll create a function called notify, and that way we can call our own little messages. So we'll say notify, hello, and we can do that kind of throughout our program, so we can easily just write stuff to the screen. Okay, so with that said, now the rest of our boot script is going to have kind of two branches. We're using that conditional that we talked about earlier. I'm going to say if the altitude radar, so if our actual distance from the ground is less than 10, then we're going to assume we're on the launch pad. So we'll wait 10 seconds and we'll copy these two additional scripts from the archive onto our own craft. And then we'll run the launch script. If we are not on the launch pad, then we're going to run this abort script. So this is logic that we actually typed into the terminal ourselves, but now we have a boot script, we can go ahead and just copy the script from within this boot script, and scripts can actually run other scripts. So that's what we're going to be doing here. Now let's take a look at the abort script, because it's much more important that we're able to recover our Kerbal than we're able to get them into space. Okay, so here we are in Kostok abort v1, and we're going to use that notify function. So we're going to say abort program initiated. Now we've got this if logic. We'll go ahead and skip over that just for now, and we'll come back to it. What we're going to say is orbital decay is achieved. We're going to lock our throttle to 0, and we're going to say set ship control pilot main throttle to 0. Now this is kind of important because whenever a program shuts down, whenever a KOS program shuts down, it's going to release the ship controls back to whoever, whatever it was initially set to. And by default, when you load the ship on the launch pad, the thrust is set to something like half. And what this will actually do is set it down to 0 so that when the program ends, it doesn't suddenly fire up the engine. Then we'll go ahead and wait a second, and we've got this loop here and say until false, we're going to stage. So this is our abort script, and basically the idea is if we need to cancel the mission, go ahead, make sure that all of the engines are shut off, do some notifications, shut off all the engines and make sure that they're not going to turn on when the program ends. We'll say we're detaching, and then we're just going to stage everything until there's nothing to do. So remember when we talked about loops, the whole idea with this until is that it will run until whatever this is true. Now, since this is never going to be true, it's just going to try and stage and stage and stage and stage until it can't stage anymore, and then the program will error out and we'll be done. All right, so real quick, let's talk about this if periapsis stuff. So the periapsis is the lowest point in your orbit. If we're orbiting around Kerbin, we have the highest point of the orbit is 100,000, the lowest point is 70,000, then this is not going to be true. The periapsis being that lowest point. Now, for Kerbal Space Program, if you're less than 70,000, you're eventually going to come back to the ground. So what we want to do is we want to say, okay, if we are above 60,000, then it's possible it's going to either take us a very long time to get back to the planet, or we may just our orbit may never decay. So what we'll do is we'll lock the steering to retrograde, so the opposite of the direction that we're heading. We're going to wait 20 seconds to make sure that we're able to point in that direction, and then we'll lock the throttle to full throttle. And now we're going to wait until our periapsis is much lower into the atmosphere, or we're out of fuel, and then we'll go through and say, okay, now we'll stage everything. So what this is going to do is it's going to say, okay, if we're in orbit already, we'll go ahead and burn so that we can decay our orbit, and then just go ahead and let that remainder fly away and land safely. Okay, so that's a lot of code talk. Before we get into the actual launch script to get us into orbit, let's go ahead and test out that our abort functionality works. So first we're going to click the scriptable control system, and you'll see now that we have this boot KS file that we talked about, we can actually set the boot file. So we can set it to none, and that's kind of the default, and it's what it was in the last episode, but this time we'll set it to run that boot KS script. So it's going to go ahead and run the launch file when we are on the launch pad, and we'll go ahead and we'll talk about that soon. But another thing that we want to do real quick is jump over to our action groups, and we've got a thing called abort. And what I've set it up here to do is if I click this, I'll go ahead and let me go ahead and reset that. I'll go ahead and say, let's go ahead and toggle the power on this thing. So what'll happen is that if we turn it off and on again, it's going to run that boot script once more, and when it detects that we're not on the launch pad, then it'll go ahead and run our abort script. So let's go ahead and save this and throw it on the launch pad, and then we're going to go ahead and test out aborting early on in the flight just to make sure that we were able to safely recover our Kerbals. And who should we send? Let's send Valentina Kerman. Alrighty, let's go. Alrighty, so we are on our launch pad, and the boot script should be running, and in 10 seconds, so it should be copying over our other scripts, and in 10 seconds it should be ready to launch. See, there we go. It's saying we're locking heading. We'll get into that, but you see this is our notify script. And up here we have this abort thing, and if we go ahead and hit it, now we're off. And if we turn it on again, see, there we go. Now it says orbital decay achieved, and it detached all the things. And yep, everything has fallen away. So the question is now whether or not Valentina will survive this abort sequence. Alrighty. Now if we just can avoid colliding into this massive thing, because remember what we had to do is just stage. So it detached everything, and these are all going to come down and start crashing into stuff. Whoa! Alrighty. So there we go. The rocket is pretty much entirely gone, but we verified that our abort script will work. Now obviously there's that condition about if we're in orbit and our periapsis is greater than 60, that sort of thing, but we won't really be able to test that until we get into space. So now that we've gone and verified that our abort script will work, let's go ahead and take a look at our launch script. Okay, so here we are in Vostok launch. Now we've got a function here that I've defined up at the top, and this is to try and keep this file somewhat short. We're going to call this tilt, and we see we're actually accepting two parameters to this function, a minimum altitude and then an angle off of the horizon. So what this is going to do is it's going to wait until we are above the minimum altitude, then it'll go ahead and notify that we are locking to that particular angle that was passed in, and then we're going to lock the steering to a heading of 0, which is going to be north, and then that angle off of the horizon. Now, so if you've ever played this game, you know that as you're trying to do an orbit, you eventually want to tilt your rocket down. It's not going to be particularly helpful to keep pointing straight up all the time. And so there are various points at which we want to start tilting a little bit further and further and further. So first, we're going to say we're initiating our launch program. We'll tilt to 80 degrees off of the horizon. We're going to say, we don't need to wait for any minimum altitude, so we'll say that minimum altitude is 0. And we'll go ahead and lock our throttle to 100%. So as soon as we take off, we want to be going full throttle. We'll wait 5 seconds, and then we'll say we're launching, and then we'll stage. So set the rockets ablaze. Now we're going to wait until our vertical speed is 300, and then we're going to throttle down a little bit. Now this took some tweaking, and typically if you're trying to do these sort of custom scripts, and depending on how high powered your rockets are, if you try and go too fast through the thicker parts of the atmosphere, the rocket can sort of spin out. So this has kind of been trial and error to figure out what the right vertical speed and throttle is for that. So now we're actually going to start using that tilt function even more. Once we hit 10,000 meters, we're going to tilt down over to 70 degrees off of the horizon. Once we hit 20,000, we'll tilt down even further. So we're going to go more and more horizontal the further the further we get up in the atmosphere. Okay, so now we've got up to 30,000, and we're going to tilt over to 40 degrees. And now all we're going to do is we're going to wait until our apoapsis, that's the highest part of our orbit, is greater than 70,000 meters. And that's technically space, according to Kerbal Space Program. Once we're down there, we're going to tilt down to almost fully horizontal and try and get our horizontal speed up. We're going to lock the throttle way down, and just try and burn out the remainder of those side engines. Now we're going to wait until our liquid fuel is 180. Now this is again kind of a trial and error. This is basically when those radial mounted engines are completely out of fuel, but we still have some left in the main engine. We'll notify that we're ditching the launch stage, and we'll throttle down, wait 5 seconds, and then ditch them. Now all we have to worry about is actually circularizing. So once we get close to the top of our orbit, we're going to go ahead and tilt so that we are fully horizontal, and then we're going to go ahead and throttle all the way up. We'll wait until the periapsis is also above 70,000, and then we'll go ahead and stop. We'll throttle down, and hopefully we should have some fuel left there so that when we run our abort script, we still have some fuel left to deorbit. Now, the last thing that we want to do is we want to actually shut this down, because remember, the computer takes a significant amount of electric charge, and we don't have a way to recharge at the moment. So what we're actually going to rely on is we're going to let the passenger hit that abort button and reboot the machine, and we're going to make sure that that boot script because we will already be in space, instead runs our abort script once it's turned off and on again when they are ready to land. So again, we're going to use that ship control pilot main throttle to 0 just to make sure that when the program turns off, we're not going to suddenly start burning fuel, and then we'll actually shut down the machine so they can just go ahead and hit the abort button when they are ready to land, and we'll jump back into that abort script. Okay, so before we take off, we need to really quickly upgrade the astronaut complex. This is going to let our Kerbals do EVAs in space. So we're going to do that. So you've got a nice little improved building there. Let's jump into the vehicle assembly building. And last thing that we want to check is that this parachute is set to deploy at a higher pressure because we're going to be coming down from the atmosphere very quickly. And since this is going to be completely uncontrolled, we want to make sure it doesn't deploy too soon. But making sure Valentina is on there and we are good to go. Let's launch this thing finally. And with all that prep work finally out of the way, we are liftoff. And you see we're already tilting over at 80 degrees. And as we start to, you can see the rockets are throttling back as we're experiencing some Mach effects. We want to make sure that we don't tip over by trying to go too fast. You'll notice things look a little bit prettier because I have installed one additional mod. I believe it's called environmental visual enhancements, I believe. I'm still kind of trying it out to see how that works memory wise. But yeah, this is actually pretty cool. We are entirely automated, and Valentina is making her way into space, much like with the original Vostok rocket was entirely automated or controlled via ground control stations. They were concerned that Yuri Gagarin would kind of be a little crazy if he was stuck being weightless, and so they didn't want to rely on him actually running any of the controls. So anyway, yeah, as soon as we get into space, one of the reasons that we're going into a polar orbit is that from there we can start to do EVAs across all of Kerbin's biomes, because you actually get different science based on what you are on top of. We can see the stars come in, which is really, really cool. But the goal here is to kind of sit in there, and we'll go ahead and fire the abort sequence once we have collected all of the science that we possibly can. Now, Yuri Gagarin obviously didn't do an EVA on his first flight. That would have been a little too crazy, but hey, this is the Kerbal way. And there we go, just losing our secondary rockets. And as soon as we get up to apoapsis, there we go, and we'll go ahead and start to circularize, at which point we will be in an official orbit. We can start the process of gathering science and working on decelerating, but alas, that will have to be in the next episode because we are running low on time, so I will hope to see you then. Cheers.